Isaac Newton, 1642 to 1727. Isaac Newton was born on December 25th, 1642, Julian calendar, January 4th, 1643 in the Gregorian calendar, in Woolsthorpe by Colsterworth, Lincolnshire, England. He was born prematurely, 3 months after his father died, and was so small that his family reportedly didn't expect him to survive. His mother remarried when he was 3, and young Isaac was left in the care of his grandmother, an experience that some historians believe contributed to his famously guarded, solitary personality in later life. Newton attended the King's School in Grantham before enrolling at Trinity College, Cambridge in 1661. He initially worked as a subsizar, performing valet duties for wealthier students to offset his tuition. At Cambridge, he studied the standard Aristotelian curriculum, but was far more drawn to the new mechanical philosophy of thinkers like Descartes, along with the astronomy of Galileo and Kepler. The plague years, 1665 to 1667. In 1665, an outbreak of bubonic plague forced Cambridge to close, and Newton returned home to Woolsthorpe. These 2 years turned out to be the most intellectually productive of his life. Working largely alone, he laid the groundwork for calculus, which he called the method of fluxions, began developing his theory of light and color, and started formulating early ideas about gravity, reportedly inspired by watching an apple fall from a tree in his garden. While the apple story has been popularized and possibly embellished over time, Newton himself recounted a version of it later in life to friends, including William Stukeley, who documented it. Optics returning to Cambridge, Newton became Lucasian Professor of Mathematics in 1669, a position later held by figures like Charles Babbage and Stephen Hawking. His early work focused heavily on optics. Using a prism, he demonstrated that white light is composed of a spectrum of colors, and that a second prism could recombine those colors back into white light, overturning the prevailing view that prisms themselves added color to light. He built the first practical reflecting telescope in 1668, using a curved mirror instead of a lens to avoid chromatic aberration. This work led to his induction into the Royal Society in 1672, though his optical theories provoked sharp criticism, particularly from Robert Hooke, sparking a rivalry that would last for decades. Principia Mathematica. Newton's most significant achievement came with the publication of Philosophia Naturalis, Principia Mathematica in 1687, funded and pushed forward by the astronomer Edmund Halley, of Halley's Comet fame, who convinced Newton to write up and formalize work he had already done privately. The Principia laid out the 3 laws of motion. 1. An object remains at rest or in uniform motion unless acted upon by a force. 2. Force equals mass times acceleration. F equals ma. 3. For every action, there is an equal and opposite reaction. The law of universal gravitation. Every mass attracts every other mass with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. These principles unified terrestrial and celestial mechanics for the first time, showing that the same force governing a falling apple also governed the orbit of the moon and planets. The Principia is widely regarded as one of the most important scientific works ever published, and it dominated physics until Einstein's theories of relativity more than 2 centuries later. Calculus dispute. Newton developed calculus in the 1660s but didn't publish his methods promptly. Meanwhile, the German philosopher and mathematician Gottfried Wilhelm Leibniz independently developed calculus and published his version first, in the 1680s. This led to a bitter and prolonged priority dispute between Newton and Leibniz and their respective supporters over who deserved credit. Modern historians generally agree the two developed calculus independently, though Newton likely arrived at it first, while Leibniz's notation, including the integral sign, and d for differentials, proved more practical and is still used today. Later, life and other roles. Newton's career wasn't confined to academia. In 1696, he became Warden of the Royal Mint and later Master of the Mint in 1699, a role he took seriously, personally investigating counterfeiters and overseeing the great recoinage of England. He was knighted by Queen Anne in 1705, becoming Sir Isaac Newton, and served as President of the Royal Society from 1703 until his death, during which time he was notably strict, some say authoritarian, toward critics and rivals, including Hooke and the astronomer John Flamsteed. Newton also devoted an enormous amount of time to alchemy and biblical chronology, subjects he took as seriously as his physics and mathematics. He wrote more on theology and alchemical experiments than on the scientific work he's remembered for today. Though this side of his work remained largely private during his lifetime and was studied more thoroughly by historians only in the 20th century, after economist John Maynard Keynes acquired and examined many of Newton's alchemical papers. Personality and death. Newton never married and was known to be reclusive, intensely private, and prone to bitter, long-running disputes with fellow scientists. He died on March 31st, 1727, Gregorian calendar, in London and was given a state funeral, being buried in Westminster Abbey, a rare honor for a scientist at the time. Legacy. Newton's work remained the foundation of classical mechanics for over 200 years and still accurately describes the motion of everyday objects. It's only at very high speeds or very small scales that Einstein's relativity and quantum mechanics become necessary. Alexander Pope's famous epitaph captures the scale of his reputation. Nature and nature's laws lay hid in night. God said, "Let Newton be," and all was light. Want me to turn this into a downloadable document or focus deeper on any one part of his life or work?